Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 10 of the 2024 released STAAR test. This is a new item type called drag and drop, and if you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it. We will look at our answers together. All right, so this is a drag and drop. We've got 2 points, right? And so let's just grab one, and you'll notice that if we take it, it grays out, which means we can only use each answer one time. And it's a 2-point problem, so if we try to move on without selecting both answers, we are going to go ahead and only get 1 point, and it's going to give us an error message. So we want to get both points. So let's take a look at the problem itself. We have a triangle PQR and it's dilated, right? So that means it's going to be, it's either going to grow or it's going to shrink. But the thing with dilations is dilated images are similar. It means the side lengths are proportional and the angles are identical or congruent. So PQR goes to P prime, Q prime, R prime. All right, so we're growing in this case. And then we just need to complete the rule. All right, so we've got a representation here. We've got quadrant 1 on our coordinate grid. So let's just take P. Point P, right? X value of 1, Y value of 3. All right. And then we've got P prime. So we have to map it to the correct dilated corner. So that's going to be P prime. Now let's get an X value of 3. And then it's got a Y value of 9. All right, so what we could do here is we can look at it and we could think of it almost like a ratio if we want to, right? There's a few different ways that we could try to figure out what the scale factor was, but one way to do it would be, let's just turn this into a fraction. I'm just going to turn it on its side, right? And I'm going to turn this on its side itself. The x being my numerator, the y being my denominator. Since we're getting bigger, we are going to multiply by something, but really this is what I'm looking at right here. I'm looking at what can I multiply by to get from 1 to a 3 or 3 to a 9? Well, it looks like it could be 3, okay? Now, in this case, it is going to be the same scale factor for both, right? We're going to multiply by 3. So what this means is if I take my p prime, right? Really what that is that's just my p. So let's just look at p now. And then we just multiply the whole thing by 3. That's what we're saying. So let's verify that with Q and R, and then we'll figure out the best way to represent that. So Q is going to be coordinates 3, comma 1, and it goes to Q prime, and that's going to be right here. That's 9, 3. All right, so if I multiply 3 times 3, I get 9. That's good. If I multiply 1 times 3, I get 3. All right, so we're good. And then we could do the same thing with R if we really wanted to, right? R is 1, 1. And it goes to R prime, which is 3, 3. And you see that pattern holds. Multiply by 3, and then we multiply by 3. So that's really what we're going to end up doing here. But instead of just multiply by 3, right, we're going to take the x value, and we're going to multiply it by 3. So it's going to end up looking like this, 3x. Same with the y value. We're going to multiply it by 3. So that's how we're going to represent that algebraically. Now we have to make sure we get the x in the right spot. So the x comes first, and then my y comes second. So the dilation here is represented by 3x, comma 3y.